We've sent rovers to Mars, probes to Jupiter, and set foot on the moon. But nowhere on Earth is more alien, more inhospitable, and more mysterious than the bottom of the Mariana Trench. This is the deepest scar on our planet's skin, a wound in the ocean floor reaching almost 11 kilometers into the heart of the Earth. To stand at its bottom is to be 600 meters further from the surface than the highest point in Canada. The trench stretches over 2,500 kilometers from the east of Japan across the Philippine Sea towards the Mariana Islands. And though it's named after the nearby Mariana Islands, it's actually located around 200 kilometers away. For the longest time, it was nothing more than an abyss. Our knowledge of it was limited by the capabilities of our ships and submarines. We knew there was something down there, but what? No one had any idea. We had no way of knowing what might live in such a dark, cold, and crushing environment until the first photographs returned. In 1960, the bathyscaphe Trieste, a deep-sea vessel, reached the Challenger Deep, the deepest point in the Mariana Trench. It was manned by two men, Jacques Piccard, a Swiss oceanographer, and Don Walsh, an American ocean engineer and explorer. They descended into the dark, spending less than 20 minutes at the bottom, before ascending once again to the surface. After all, they could only stay as long as their oxygen supply allowed them. But what they saw during that short time changed the world. Walsh described it as a desolate lunar landscape. There were no fish or plants or animals, just the hard ocean floor. Of course, that turned out not to be completely accurate. Since those first glimpses, we've realized that the bottom of the Mariana Trench isn't a barren wasteland. Rather, it's home to some of the most alien creatures in our oceans. From giant squid to xenophyophores and snailfish, many of these creatures have translucent bodies, allowing them to blend into the darkness. And others have evolved enormous appetites to consume the scant matter falling from the upper layers of the ocean. As you descend into the depths, you would pass through layers of the ocean known as the epipelagic zone, the mesopelagic zone, the bathopelagic zone, the abysopelagic zone, and finally, the hadapelagic zone. You wouldn't see any marine life in the first layer. That's because the sun doesn't reach deep enough here to sustain plant life, which is necessary to support most marine food webs. But when you reach the second layer, you start seeing the beginnings of adaptation. Bioluminescence becomes common. Fish begin to develop large eyes to spot prey and predators in the darkness. The third layer is where you'll find the famous anglerfish. The fourth layer is where the temperature drops to near freezing, and the fifth layer is where the pressure is thousands of times greater than at the surface. It is also home to the bottom of the Mariana Trench. It's an environment so harsh that it seems life should simply not be able to survive there at all. Sunlight, which drives most of Earth's energy, can't penetrate to these depths. The average temperature is just above freezing, and the pressure is intense enough to crush most ships. Even the largest whales avoid this region. So how do any creatures survive down there? Well, it helps that most life in the trench is tiny. Crustaceans known as amphipods make up much of the biomass in the trench, along with sea cucumbers and other scavengers. These creatures feast on organic matter that drifts down from the upper layers of the ocean. The sparse food supply means that the creatures that eat it don't need to expend much energy to get it. As a result, they tend to live very long lives. In fact, some amphipods found at the bottom of the Mariana Trench live to be 30 years old. By comparison, the average lifespan of an amphipod that lives in shallower waters is about 2 years. That's because the abundance of food in shallower waters means they expend lots of energy finding it. Their bodies need to replace themselves quickly to keep up. Meanwhile, the lack of food in the trench means they conserve energy by slowing their metabolisms down to extremely low levels. Some may enter a state known as cryptobiosis, a form of suspended animation that allows them to survive extreme conditions. Scientists believe they achieve this by slowing their metabolism down by up to 99%. There are also larger animals living in the trench. One of the most notable is the Mariana snailfish, which grows to about 27 centimeters long. Its body contains high concentrations of antifreeze proteins and ices in its cells that help it survive the freezing temperatures. The snailfish has also been spotted around hydrothermal vents, areas of the ocean floor where superheated water containing chemicals spews out. Though many of the creatures living in the trench feed on organic matter drifting down from above, Others survive by harvesting energy from the chemicals in hydrothermal vents. But while the creatures living in the trench are tough and hardy, it's the bacteria in the trench that truly steal the show. The soil of the Mariana Trench is rich with a variety of microbes. Thanks to the frigid temperatures and crushing pressures, these microbes are unlike any found anywhere else on Earth. And despite the lack of sunlight, the floor of the Mariana Trench is actually a hotspot of biodiversity. Prokaryotes have been found to make up 80% of the biomass at the bottom of the Mariana Trench. And yet, for all that, we've probably only discovered around 1% of the microbial species that live there. Many of these bacteria live in a layer of sediment that sits on top of the bedrock of the Mariana Trench. Others grow in microbial mats that cover rocks exposed by volcanic activity, and others cling to surfaces in dense biofilms. And yet, despite the fact that these bacteria are incredibly diverse, they're barely visible to the naked eye. They're between 0.5 and 2 microns wide. For reference, the width of a human hair is around 80,000 microns. These bacteria are so small that researchers studying them have to extract DNA from them before they can identify the different species present. These bacteria play an essential role in the ecosystem of the trench. They recycle nutrients released by dead animals, decompose organic matter, and capture carbon dioxide, storing it in their cells. Most of them don't use photosynthesis, but instead rely on chemotrophy, gaining energy by oxidizing inorganic compounds. For example, some obtain energy by oxidizing iron or sulfur. Others get energy by breaking down methane, ammonia, or nitrogen. Many of these bacteria depend on hydrogen sulfide, a gas that is toxic to most life. But some bacteria convert it into energy. The remaining energy they use to synthesize organic compounds, allowing the bacteria to survive and grow. In recent years, researchers have been able to cultivate some of these bacteria in labs, which has allowed them to study the bizarre adaptations that allow them to survive. For example, some of these bacteria can reproduce incredibly quickly, doubling their population every 40 minutes under optimal conditions, and in the wild they can form spores that remain dormant for years before conditions become favorable once again. Because of their incredible adaptations, bacteria are able to thrive in the harshest parts of the Mariana Trench, including the deepest point, the Challenger Deep. To reach the bottom of the Challenger Deep is to venture to one of the most inhospitable environments on Earth. Descend over 6,000 meters below the surface, you'll experience a crushing pressure of around 1,000 bars. It's roughly equivalent to the pressure at the bottom of a 100-meter high dam. The temperature is just above freezing, and no sunlight reaches this depth. If you try breathing down there, your lungs will collapse and your blood will boil. That's because the pressure difference between the air in your body and the water outside will cause gases in your blood to dissolve, leaving you with potentially fatal consequences. Of course, the creatures that call the bottom of the Challenger Deep home don't have lungs or blood that boils, and so they have no problem surviving there. But for humans, this environment is a death sentence. So how do we explore such an inhospitable place? Over the years, scientists have come up with various ways to explore the bottom of the Mariana Trench. The first manned descent into the Challenger Deep was made in 1960, as mentioned earlier by the Trieste. Since then, a handful of people have explored the bottom of the Mariana Trench, each descending in specially designed vessels that can withstand the crushing pressure. However, each mission has limitations. No one can spend more than a few hours at the bottom of the Challenger Deep without running out of oxygen, and bulky equipment can limit a person's range of motion, making it difficult to collect samples or conduct experiments. So in recent years, researchers have turned to smaller, unmanned vehicles to explore the trench. Some of these are remotely operated vehicles, which are controlled by humans on the surface. Others are autonomous underwater vehicles, which follow a preset path without human input. These vehicles are much more nimble than manned submarines and can reach places that humans never have. However, exploring the bottom of the Mariana Trench still comes with challenges. For example, the intense pressure can damage delicate equipment, and the cold temperature can limit the amount of time a vehicle can operate. But engineers have come up with solutions to these problems. For example, they've developed cameras and other equipment that can withstand the pressure of the deep sea, and they've created vehicles that can be powered by the cold temperature of the deep sea, eliminating the need to carry batteries or other power sources. In recent years, these technological advances have allowed scientists to make incredible discoveries in the Mariana Trench. From the strange creatures that live there, to the chemical activity of its floor. But even with these advances, there's still so much we don't know about the Mariana Trench. We only explored a tiny fraction of its volume, and we probably only identified a small fraction of the species that live there.
Ow.
Now watch what happens when the world's oceans vanish.
Ow.
Or check out this video instead.